All set, streaming in. So, very good evening to one and all present here. Hope everyone is coming out there in live. And here we go. Five, four, three, two, one. Yes. Very good evening, guys. I'm founder Subhash Kupasamy, Brahmastra Group, Chennai. I'm scientific advisor of Novatech Labs, former HAL project trainee, Bangalore. And I have started this Brahmastra Aerospace Systems 6 months ago, and I have made this quarantine space webinar inspired from an international space webinar. It is an unplanned session and unplanned webinar. It got stuck in my mind and it got heated. Thanks a lot, guys. Those who are subscribed, and I'm overwhelmed with every participants. I have to say this. I have to say this because 140 subscribers, 140 subscribers in 24 hours for a startup is a god thing. I could say it's a god thing. Yep, it happened for me. Happened for Brahmastra team from Bastra. Yes. Today I'm going to take the class. Sorry, the webinar on. Hmm, yes. Sorry. Introduction to Aeronautics and Astronautics. Okay. Brahmastra Aerospace Systems is well versed in aeronautics and astronautics, and we started this Brahmastra Aerospace Systems only to make aware of the aeronautics and astronautics in India, so far for the world too. Yes, let's go to the session. Let's see the aeronautics in a nutshell at initial times, because aeronautics is not a tough subject as any people have seen in this world. It is a very easy subject if you guys have a common sense. Yep, it is. Let's go and see this. Yeah, evolution of a king. Um, I could say aeronautics is a king of sciences. I could say aeronautics is a cluster of sciences like physics, maths, astrophysics, everything will be there. But I could say for my thing, aeronautics is a king. Let's see the evolution of the king. We will be thinking that Wright brothers, Wilbur Wright and Orville Wright started this. It all sort of from there, but it's not. It all everything's needs an inspiration, right? We wanted to fly at initial stages. We have seen the birds, we have seen the dolphins like belugas. We wanted to fly anyway. We have seen the cockroaches, we have seen the cows, we have sorry crows, we have seen the pigeons. We would have inspired a lot from the crow, what's that, vultures. Yes, of course we wanted to fly. The thing is, we imitated falcons, dolphins, yes, Petriosaurus. Yeah, they will fly like anything, right? We have seen in Jurassic Park. And dolphins, we have imitated dolphin in Beluga, and Falcon F-22 is there. We need speed. NFS, most wanted thing for our life, man. And the aspiration to spread the wings and fly. We wanted to make our wings to the greater heights, to the greater levels. We wanted to fly, of course. We wanted to make things better, right? So we are doing it. Let's know the kingmaker first. Okay. If aeronautics is a king, then who is the kingmaker? Whether the Wilbur Wright and Orville Wright? No. Here comes the king maker, Sir George Cayley. Sir George Cayley is known as the father of aeronautics. Um, excuse me. Hello. ப்ரோ, புது பேஜ் என்ன சொல்றது, புது லிங்க் ஆயிருக்கு ப்ரோ. திருப்பி பிரச்சனை. என்ன சொல்றது, சேனலுக்கு மட்டும் போங்க. ம் Oh, he coined the term modern concept of fixed wing theory. He coined mostly the terms weight, lift, drag, and thrust, right? Okay, I'm so sorry. Okay, let us see weight, lift, thrust, and drag. People have seen, what is it? The people will be saying that the types of aircrafts and everything's like that. But the thing is, the aeronautics majorly depend upon these four big words: weight, lift, thrust, drag. Without these four words, you cannot even think about aeronautics. And of course, let us see what is lift. Okay, lift to the top floor. Essential force to fly an object under gravity. Right? And here is a very close buddy to the weight. Yes, he is very close buddy to the weight. He is a very close buddy to the weight. Always comes up with the, yep. If lift comes up there, there would be weight. If weight comes up there, there wouldn't be a lift. No weight, no lift. Of course, yes. If there is no weight, there is no lift. Technically, he makes everything fly. Without the term lift, there is no term called, sorry, flying. The next word is drag. Drag him down to the floor. Yep. The word of the word drag is to drag the aircraft. He's a bloody bad guy. He's a very, very bad guy. And he make make your aircraft fall down. Yep. If he wants to make your aircraft fall down, okay, he will make your aircraft fall down, right? When boredom hits him. You get it? He is a close buddy to the thrust. When thrust falls down, drag makes the aircraft fall down. Yep. Um. Okay, I'm not going technically. Why? Because I'm not going technically is most of the people here are not from the technical side, so I'm going very basic things, right? Drag is very simple guy. Drag is a very simple guy, and when thrust comes down, drag. What's that? The drag takes over. Weight. Weight. We all know about the weight, and he is very down to earth because whatever you make it on the space, he will go to the earth. That is the word. That is the term of the earth. And he loves Newton's law of gravity. Newton's law of gravity is whatever you make to to be there in the space of under atmosphere, it will come to the ground, right? Of course, he loves gravity. Literally, he is everything for aeronautics. Without weight, there is no you cannot, as I said, you cannot term aeronautics without those four words: lift, weight, thrust, and drag. Literally, he is everything for aeronautics. The contrary thing and the contrast thing about the weight and the astronautics is we won't consider the weight in space. We won't consider the weight in space because the weight only acts in the inside the atmosphere. Outside the space, there would be the weight would be calculated as mass. The next term is thrust. Thrust is a term is used to make the aircraft go in a faster way. You get it? Yep, thrust loves Fast and Furious. He's a very flatter guy, faster guy, and his enemy is drag. The drag, as I said, he's a very bad guy. You get it? Whenever he thinks, he will be making negative vibes to thrust, and he works with the engines, right? The thrust is 100% connected with the engines. The engines makes the thrust, and I'll be explaining about the engine soon. And in the previous, what's that? The forthcoming, what's that? What's that? Slides and engines. If we take the engines, we have known about the Rolls Royce Phantom and like those cars, but most of the people don't know about that. Rolls Royce is famous for making aircraft engines. Yep, they make the world's powerful engines, turbofan engines. Here comes the skeleton of the aircraft. The aircraft majorly consists of fuselage, empennage, wings, what is that? Primary control surfaces, secondary control surfaces. So primary control surfaces considers as ailerons, rudders, elevators, flaps. What is that? The elevators and what is that? Elevators and flaps concerned to the secondary control surfaces. And yep, the landing gears, empennages. Yeah, you can see this in this. What is that? This diagram. Engine cowl, landing gear, propeller. Yes. Let us go for the propulsion thing. You guys have seen and you guys have known about the two-stroke engines, four-stroke engines, and I'm directly jumping to the turbojet engines. Let us see turbojet engines. Turbojet engines are like humans. The turbojet engines are human like humans. It is written there, right? Like humans, it has four stages. We inhale, compress with our lungs, we exhale. Before that, we separate the oxygen and the blood, right? Likewise, suction, compression, combustion, and exhaust are the four major and the one and only steps which is takes place in a jet engine. So as in the two stroke engines too. And the types of the turbojet engines are turbojet engine, turboprop engine, turboshaft, and what is that? Turbofan, turbojet, turboshaft, turboprop. And who are all the guys who are making these engines are Rolls Royce, General Electric, Pratt and Whitney makes them. Uh, Let us see the turbojet engine first. Guys, a minute. There was a problem in our old video. Turbojet engines. Turbojet engines are, yes, I said, as I said, it is there: intake, compression, combustion, and exhaust, right? And here, let us go there. Let us here. Here, the aircraft sucks up the, what is that? It is known as cowl. It is known as cowl lips. In this cowl lips, the aircraft sucks up the air from the atmosphere, and these things are known as, what is that? Compression chambers. These type of compressor here, these type of compressor here is a stage by stage compressor, and it is 12 stage compressor, it seems 12 stage compressor it is. And the next thing is compression. After the compression, the combustion takes place. Before the combustion and compression, the fuel and air mixes up there. The fuel and air mixes up here, exactly here, I could say. The fuel and the, what is that? The compressed air and the fuel and the fire mixes up there. Exactly here. After this, here is the turbine. The work of the turbine is to make, to produce the power. For what is that? Let us consider, if we go for the turbofan engine, we dwell on the thrust. If we take the turbo, what is that? Well, let us see in the next tab. Yeah, it is turbofan engine. This turbofan engine is made by Rolls Royce. This turbofan engines is made by the Rolls Royce. I forgot about the name of the engine, right? Yeah, let us see this. Why it is made here with the bigger fans is, uh, there was a lag in turbojet engines. There was a lag in turbojet engines. The lag was very high temperature, and the turbojet engines fails very easily because of it. It was that the normal temperature of the aircraft engine is more than 5,000 degrees, right? Due to the more than 5,000 degrees, there is fatigue and failure happens inside. The heat failure is there, creep is there, fatigue is there. The everything will be taken place exactly here. Exactly, I could say here and here. Because of that, the engine fails fastly. So that the people came up with an idea of making cooling the aircraft engine, right? So what they made is, they made the front portion of this part, that is the engine's cowl lip, has been increased. The size has been increased. What is that? I could say 1:3 size. Yep, we can say. Because of that, the cooler air comes in here. Cooler air comes in here. I transfers in a double way path. See, you can see the flow of the air flow here. The air moves inside the turbine here and the air moves outside the turbine here. The why the fan flow is given here is it cools the engine. It literally cools the engine, right? So there is another trick here. There is another trick here. I could say, uh, in the fighter aircraft, there is a term called afterburner. The afterburner will be placed in this position. I could say in this position, the fuel will be mixed up with the air, the unburned fuel, and the higher pressure. What is that? The higher pressure air will be burned again. If the afterburner is on, the you can say the speed of the aircraft would be more than, it's according to the engine. I could say it's according to the engine. It can go beyond the superphone. What is that? Beyond the supersonic. Beyond the supersonic. I'm sorry. I'm distracted with the this live video. I'm really sorry because there was a technical issue there, and I'm solving it by myself. I'm sorry. Yeah, here comes the Turboshaft. This Turboshaft, guys, mostly dwelling on where? Helicopters. You can see it is gear and it is see it is gear powered. You can as what is that? It is like the turbojet engine. The air comes here, the compressor compresses the air here, the combustion chamber increases the temperature here by burning it, and after this a turbine is connected here. That turbine is connected with the reduction gear here, right? This reduction gear reduces the rpm of the turbojet. What is that? Turbojet engine. It is actually the turbojet engine. It is something what modified in turboshaft, right? Why? Because we are using the reduction gear here is, why we are using the reduction gear here is, uh, if we use the rpm of the turbine engine into the propeller of the helicopter, the rpm would be more than a lakh, right? At least 50,000. If the propeller reaches the 50,000 rpm, literally there would be shock waves will be forming. Because of that shock waves, at first this propellers will break like anything. It will break like anything, right? It will break like anything, and it is the worst thing you can expect in your dream. That is a nightmare when a propeller, what is that, burst when an helicopter flies. Yeah, here comes the turboprop engine. You guys have seen the turboprop engine. You guys can see the turboprop engine here, and this turboprop engine is made by General Electrics, and turboprops were mostly used not for the thrusting but for making the powers. Why? Because we are using the turbojet engines for powers. There is two type of aircraft categories, I could say. uh, the one is for the faster, the another is for heavier, to take off the heavier loads, to take off the heavier loads at a higher conditions, I could say. uh, let us take Antonov 225 and yeah, Donia 225. These are the aircrafts, those who use the turbo propeller, so that is turboprop engines. They give more power when compared to the turbojet engines. Yep, they work on the propellers, right? Let us go to the aerodynamics. Aerodynamics is my lovable subjects. Even if you come to my what is that library here, yeah, he is there. He's there. He's lining up there. Yep, he's somewhat a tougher guy. He's a bloody tougher guy, but he is a lovable character. The study of air and its properties known as aerodynamics, and he is the son of the legend, fluid mechanics, I could say. Uh, why we are saying the aerodynamics as son of the fluid mechanics is the air and water are same. The air and water are literally same. The air and water are literally same. The if you take a scale, if water is 1,000 in density, if water is 1,000 in density, then air is 1 in density, right? So fluid, if you want to analyze a thing in aircraft wind tunnel, you can use for smoke tunnel. Yeah, smoke tunnel is a very easy squeezy thing for making analysis. Yeah, you can use it for visual analyzing too. Harbhajan Singh, Ravichandran, Ashwin are the champions because of him. Why? Because there is a thing called Magnus effect. Because of the Magnus effect, the spin bowling will be very what is that, easier for the spin bowlers. And so as the Ronaldo's knuckleball click works behind aerodynamics. Yeah, as I said, the Magnus effect is here. The force exerted on a rapidly spinning cylinder or a sphere moving through another fluid. I'm sorry with this theory, but it should be there. The magnetic effect is nothing but let us take a ball. Let us take a ball. In that ball, uh, if one side is rougher, if one side is rougher and another side is smoother, the aircraft turns automatically to the rougher side. It is what the Magnus effect, and by using these tricks, the spin bowlers make things. And let us go for the aircraft structures, right? The aircraft structures is nothing but a nightmare to the normal peoples. Yeah, he is a mixture of high school mathematics and physics. Without knowing physics and mathematics, you can't even touch him. You get it? A simple common sense is enough to know him. Yep. He's just an updated version of vector mathematics. Let us see here how a normal aircraft structures problem would be. We have to find tip deflection. The wing of the small plane is represented by a simplified prismatic cantilever beam model acted on distributed loads shown in the figure, right? See here, it is known as the distributed load here, and it is UD. What is that? It is U. What is that? It is UDL here, and it is UVL here. It is varying, and it is not varying, and it is varying again, right? They have given the elasticity modulus and what is that, rigidity modulus as 1,000 kilonewton meter square to find the deflection of the rotating nut B. At this point, we have to find the rotation. This is what I have said. This is a nightmare for the people, those who don't know physics and mathematics. I'm really sorry, guys. The next thing is flight dynamics. We have to make a statutory warning here. These stunts are all dangerous and potentially fatal. Do not attempt any of these stunts without proper training. Yep. If we take flight dynamics as a code, he is the judge. Yep. Without his rules and regulations, you can't even run or fly an aircraft with a stability, right? He works out equations as deadly as Breaking Bad professor, and but we can tackle him like a money is professor, right? Uh, Only you can tackle the flight dynamics by knowing the aerodynamics, propulsion structure, and common sense. Without these things, you can't even think about flight dynamics. And his what is that? His life principle is very simple. Lift is equal to weight, thrust is equal to drag. It is an equation there for a steady state flying aircraft. It is a rule that for a steady state flying aircraft, the lift is equal to weight and thrust is equal to drag is the rule you have to follow in each and every problems you have to solve in the flight dynamics. You get it? You can ask me why you guys are studying the flight dynamics. I have the bloody um, aircraft propulsion, aircraft aerodynamics, aircraft structures. Why I need to flight? Why I need the flight dynamics? See, the flight dynamics is the heart of what is that? If um, the aerodynamics, propulsion, thrust, and the structures are the skeletons. The flight dynamics are the heart, right? Without knowing the what is that center of gravity, aircraft center, aerodynamic center, center of pressure, you can't even tackle this flight dynamics. I could say. Let us go for Astronautics. Yep, my favorite part, I could say. I used to make researches with nozzles 3 years back. Nozzles on Bell nozzles for secondary injection thrust vector control. Um, yep. I'm sorry for making fillers here because I'm alone here. We are in webinar and we are in quarantine. I can't even see your comments here. Let me see the comments first. Astronautics. See, astronautics is nothing but astronautics is a part of aeronautics, but astronautics work without a term gravity and atmosphere. As I said before, it works on the principle. Um, what's that? It works on the principle without gravity and without atmosphere. You get it? Since then, he had a fight with Newton. He works away in atmosphere, sometimes inside too. Why? Because it is mentioned some side, sometimes inside too is. Let us take some missiles. You get it? You have to apply the astronautical force inside. What is that? Inside the atmosphere. By what is that? While calculating, you have to add the gravity also. That's it. You have to add the gravity. That's it. That's it. That is more than enough. And yeah, we need what is that? We need what is that? We need atmospheric temperatures and conditions according to international standard atmospheric data, right? Astronautics is a favorite guy for Elon Musk. Recently, Amazon shipped them too. Let us see rockets. These guys are like town buses. They come, they go, they come. It used to be a single used capsules in 1990s, even in the 20s, even in the early 20s. But a guy whose name is Elon Musk, who founded the SpaceX, who was one of my inspirator. What he did is he made the aircraft, what's that, the spacecraft like town buses. See, if you go and subscribe the Elon Musk, what he will do is literally for a month he will be launching a Falcon Heavy into the International Space Center, space station. Why? Because if you ask him, means, hey guy, I want to just supply the foods and things to the International Space Sector station here, like that he will say. And recently, what that sarcastic guy did is a literally hilarious thing. What he did is he tested the Falcon Heavy. Falcon Heavy was a biggest aircraft, was that spacecraft he has ever built before 2 years. Because now, as of now, there is another guy called BFR, Big Falcon Rocket. There is another word too, Big Falcon Rocket. I'm sorry, I'm blanked out. Big Falcon rocket. What he did is he put up his own Tesla with a Starman suit inside it. He made it to the space. He literally made it into the space. Let us see what he has done right. As I said, This is the guy who is roaming around the space. This is the guy who is roaming around the space. It is launched by SpaceX. It is launched by SpaceX. Mm, let us go for the missiles. Yeah, these guys mostly work on the escape velocities. See, let us see what is escape velocities. Escape velocity is the minimum speed required for an aircraft or spacecraft to escape the atmosphere of the massive body. See, if you take and if you take a celestial body, what is that celestial? What is that? Let us take this. Let us take my mobile. If I want to fly this mobile outside the atmosphere, means what I need is an escape velocity. The escape velocity of atmosphere of the Earth is 11.86 kilometer per second. I think so. Yes, of course, it is correct. And you need 11.186, 11 point. Yeah, let us consider. Let us 11.1 kilometer per second. We need it, right? It is denoted by VE, and why we mostly work on the propulsion thing is the reaching the escape velocity is very tougher to anyone. It is very tougher to anyone. Hmm, that is what we used to have. What is that? What we used to have is um, solid rocket propellants. Solid rocket propulsion before. What Elon Musk did is ultimately, literally, you can say it is idyllic. What he did is he replaced the solid rocket fuels with kerosene. Yep, he is using kerosene as his fuel. RP1 is the RP1 rocket propellant one is the fuel's name. If you go more technically, RP1 it is the very most uttermost purified gasoline. Sorry, it is not gasoline, it is kerosene. So let us go for the missiles here. Missiles. These guys are very dangerous. Why? Because the fat guy and the little guy thrown out in. Okay, wait a minute. Okay, missiles. Missiles. These guys are very dangerous because the Hiroshima. Okay, missiles. Missiles. These guys are very dangerous. I'm really sorry because it is again a technical issue because I have seen the what is that? I have seen the live. I have seen the live. I'm really sorry. Let us go for the missiles again. And these guys are very dangerous, of course, right? These guys are very dangerous, fatal, and they are very critical thing because they are the ones who target. See, the simple example for the missiles is bullet. Literally, it is bullet. Their targets are achieved only by destroying. Yep, I have seen this quote somewhere. I have took it. Missiles are the real destroy in seconds. We have seen it in Discovery. These guys are the destroy in seconds buddies, and one of the destroy in second what is that seconds buddy from India is BrahMos. It is an intercontinental ballistic missile, and it will what is that? Literally, it will go more than 1,500 kilometers. Guided missiles. The guided missiles are. mm, It is not the simple difference between the rocket and missiles are the rockets are pre-planned. Their targets are fixed. Their targets are what is that? Their paths are fixed in everything space. But if you take the missiles, there is a term called I'm really sorry guys. I'm really sorry guys. BrahMos is a notable. What is that? BrahMos is a notable missile by India. It is not a ballistic missile. It is a cruise missile. Uh, Let us go for the conventional guided missiles. Uh, the conventional guided missiles are air-to-air missile, air-to-surface missile, anti-ballistic, surface ballistic, wire-guided. See, let us see the air-to-air missile. Air-to-air missile is nothing but the missile launched during the dogfight between the aircrafts. It is heat-seeking missiles mostly, and air-to-surface missiles. The air-to-surfaces missiles is like you can say bombshells. Bombshells are the one of the main examples for the air-to-surface missiles, and I don't know whether yep the you can say fat guy and little guy are also the air-to-surface missiles and anti-ballistic missiles. And anti-ballistic missiles are what is that? Anti-ballistic missiles are launched opposite to the ballistic missiles, and surface ballistic missiles are launched from the normal grounds and wire guided. See, wire guided are like of course I'm sorry, bombshell is not also a missile, but um, um, I'm sorry guys, I'm blacked out. I'm blacked out. Anti-ballistic missile, surface ballistic missile, and wire-guided missiles. You get it? The next thing is cruise missiles. Cruise missiles are the missiles which, yeah, I got it. Ballistic missiles. Ballistic missiles goes out the atmosphere and comes again, and it reaches the atmosphere. But while the cruise missiles goes inside the atmosphere. Yeah, this is the very perfect example. This is the perfect example between the uh, cruise missile and the conventional guided missiles. Yeah, let us go for the cruise missiles. As I said, the cruise missile goes inside the atmosphere. They are mostly ground launched. Cruise missiles are air launched, ground launched, and submarine launched. And if you take, the thing shown here is the what is that submarine launched ballistic missile. It goes from inside. It goes from the what is that here? I'm sorry. I'm showing my hand here. It goes from here to the surface to the space, and again it hits the what is that target. Mm, what's that? It is more than 46 minutes, and you guys are bored, of course. Here comes the end session. The webinar is coming. The more webinar is coming, it will be taken over by the people, and people write personal queries. The people write personal queries to the live chat here, and I could be answering through my mail. Whatever the mail you ask or the queries you ask, I'll be answering it within 2 hours. I could say within 5 hours. Sorry, 5 minutes too. Okay, that's all, folks. Let us go for the queries. That's all, folks. Here ends the session. Okay, bye.